So in yesterday's class, we were here actually, right? We were somewhere here. We wrote all of them there. So
Yes, sir.
can you tell me what your answer came after adding, multiplying all of them? What came at last?
The 1926.4922.
Let me see. What is your answer came?
1926.4922.
Okay. What others? आप लोगों का?
Same, sir.
Sir, same. Sir.
Let's see. Nobody got anything different also?
No, sir.
So just 10 points. Rest of the answers.
Points was okay. That sometimes you can round off, sometimes you can do that way, no? Points
Yes,
is
sir.
okay. So 1926.49, right?
Yes, sir.
Yes, sir.
Okay, that's what the answer is. So this is what you have. Now you did this from power difference. Can you do the same thing for backward difference? Did you try for that?
No, sir.
But you should have tried that because that is given to you. The same thing can be done by. Yeah.
Sir, will the answer for the backward and the forward difference will come same?
Yeah. No, it is not, because that is the different technique. So each technique will give you the different answer.
Okay.
Okay, so because these are the some techniques, because each technique may not give the same answer to you. So you are supposed to use to calculate this from your same thing from your forward difference also. So you have backward difference. Sorry. So your backward difference expression is this only. So same thing with there, and you are just finding from your yn, right? You are the starting from now from your yn. So your yn is if you see your table yesterday is we drawn that table, no? Difference table. I think we were here. So yesterday you were here, right? So if you are taking this, you have the del y0, del y0, del square y0, del cube y0, del 4, del 5, 6, 7, and all of them in terms of y0. If you will go from this side, now in terms of this is del yn, del square yn, del cube yn, del 4yn, and then continue to that way. So in case of backward difference, you are going from this side. Fine?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
But you also told us that if the value like it's 10, it's lying in the upper range of this table. So we will use the forward difference method. If it's lying from the middle, then
those are guidelines. But let's say a person wants to calculate by both. Person wants to know. Because those guidelines come from practice only, no, right? Because if you do from backward, if you do from forward, if you do from central, and if you will use some other technique also, and then only you can, those guidelines, whatever I say is correct, but those all based on your own calculations, then only you can also come to know, right, that this is whatever is being written is correct or not. So you have techniques. You should start from doing calculation from all of them, and then only you can tell, okay, this is what is the rule is, this is what it is verified also. Fine. So we want to calculate, do the same calculations because we want to be expert or familiar in all calculations. So we should know how to do for forward, we should know for backward. Okay. So same thing you will do for a backward one. And if you want to quickly finish it here, you can just do it now, or if you want to take time, so you can do at home and do it. What do you want? Everybody have calculator or not?
Yes, sir.
Yes,
Yes,
sir.
sir.
So would it be possible to you calculate it within 5 minutes? If possible, you can cross check. Is it possible?
So not within
Mm.
5 minutes.
Okay. Why? Because these are a lot of calculations here.
Yes, it will take some time.
Okay, so I have told you this, so you should have in next class then you should complete it then.
Yes,
Okay?
sir.
Yes, sir,
Yeah.
yes.
Yes, sir.
So once you did forward, backward, and then we also wrote there Lagrange, right? We also wrote for all forward difference, backward difference, and then Lagrange interpolation, and then linear interpolation. So you will get answers at all these. With that. So here you will get answer for each time. Let's say for you are calculating for 10, you will get there how many answers? 5. One for backward, one for forward 2, one for Lagrange 3, one for the linear integral, 4 answers. At t equal to 10 hours, you will get 4 answers, all these 4 techniques. Then 50 also 4 answers, 90 also. So you will calculate all of them and then you will see which one are very close to each other. So whichever will look so close to each other, those are actually, you can say, correct answers. And then you can also see the correct answer from here, because if your answer need to be in a particular bracket, so obviously if it is coming in that bracket, that's fine here. Other thing is that what can be done, because that is the easiest possible way all the time, need to be done in all, everywhere actually. What is that? Plotting. Plotting is always is advisable point that let's plot all the time, because this we are talking about computational path. So we should always have a plotting type of habit, and we see what the trend is and how the things are going on. So if you will say insert this line here, this one. So this is how your data are, correct? And then you can always find a best fit line for that. That is always in your hand. Okay, so that's always in your hand. And then you keep on seeing that how is it passing from your all data points or not. So you can see this looks slightly better. Yes or no, compared to previous one? Because
Yes, sir.
previous one was this. Many of data points were here, there. Now you change it slightly better than previous one. Maybe you can change further better. It's going now, let's say, from all points. Yes or no?
Yes, sir.
Correct? So as
Yes, sir.
most of the time, as you will increase your degree of polynomial, you are going better and better fit. Let's see here now the fifth order looks much more better than fourth order. Correct?
Yes, sir.
So you can display the equation, you can display your R value here. So you can see your R square. So this is your equation of line, and this is your R square 0.996. So as you will go close to 1, your fitting would become better and better actually. So So that way you can always try to have this fitting it. Now you can have maybe fifth, sixth order. You will have find no change here. Sixth order and fifth order. Previous it was fifth. There was no change in line. Sixth order, your equation slightly changed, but as you see the visual change in the graph, you cannot find because visual change means now you already have a best fit type of thing. And this R value is also not changed. If you say the sixth also, R value is 0.9962 and fifth, sixth also R value is same. So R value is not changing. So you are not getting any better fit. But to solve the sixth order polynomial, you have to do a lot of work. Okay? So because you will get now 6 unknowns, you have to do 6 unknowns fittings. Calculation, your computational time is increasing. However, you are not getting any change in fitting or your error in the answer. So you have to always constrain what fit do I need to do. So this is what you are best fitting. Now this can be done for all sort of your differential technique. So you always have a data, do a polynomial fit there, which passes from all point, and that is your best fit because that is passing from all point. Now you have polynomial, you can put your unknown there, you can get your variable. Yes or no? Because this is the function of y and x. You substitute the value of x, you will get the y. Fine.
Yes, sir.
Yes, sir.
So this is also the another technique. First, you can fit a polynomial to that, or then after that substitute that. That is also one of the technique, just to find your unknown value at any given value. Fine. So you can do it 7, 6 also because the MATLAB go to 10 to the power 14, polynomial 14 also. Excel sheet cannot go beyond 6, so yeah, it will always cap on the 6. But by 6 order, your fit are quite good actually. So this will give you the correct answer there, and now from here you compare your calculated one. Then you will come to okay, this technique is good in this particular range, or whether I to go as I told in previous class. If you are close to in the beginning the data range, use forward. If you are close to in end range, go to backward. If you are somewhere in the center, go to the central one there, right? So these are the based on these particular experiments only. Okay.
Yes, sir.
Now we have the next part here. This question I think you would complete by tomorrow's class. And for backward, your forward, for your Lagrange and linear also. So you will make a table there. A table, once you do all this calculation, in that table you will say time t equal to 10. Your answer from forward is this, answer from backward is this, answer from Lagrange is this, and answer from linear is this. So you will make that way. Fine?
Yes, sir.
Sir, so what will be
Okay.
the answer for T220R? We don't have the concentration for 220.
So what? These are the interpolation techniques. They work for interpolation, they work for extrapolation, they work for interpolation and extrapolation. They will calculate it. Don't worry.
Okay.
Just like this graph, जो आपने बना दिया, right? This you got line now, right? Yes or
Yes, sir.
no? Now you can substitute here any value of the x here. So this will calculate. Only thing is that it would be 100% exact answer if you are there and given the range, because now you have best fit there, right? You have in given range from 0 to 200, you will get 100% correct answer from this fitting. But if you are talking about 100, 210 or 220, it means you are expecting that this graph should go somewhere, something like that. That's what its trend is, right?
Yes, sir.
So, but it may be possible that it may become something like that. So extrapolation and interpolation are always have question mark because you are considering same trend line to continue. But that may or may not be possible. Fine?
Okay, sir.
Yes, sir.
Same thing here also. If you want to create this line, would extend this side only, that way. Horizontal type of thing, which may or may not be true. But this side in between of data range, you are always correct. So therefore, extrapolation and interpolation are not advisable to a very far away point. Very close is okay, well, that's fine. That may train may continue. But if you are talking about very far away, those are always a question markable thing. So you see that nobody do the future for forecast very well, because future forecast we always do the from previous trends, just like your financial market, this, that, and everything. So okay, you have in range, you have data in that range, you are good in that data, but you cannot predict after that actually in that same trend, right? So future prediction is always question markable. Fine.
Yes, sir.
Uh, so now you have after those techniques, one more is there, the divided difference interpolation technique. I hope you don't have any doubt. Only thing, these need a calculation, power difference, backward difference, and the Lagrange. Now you are getting more and more calculations here. So here you have 10 data points. So you have 10 steps. Then you have more. By chance you have done real practicals in plant, sometimes simulation part. You have many data points. So these by hand calculations would become tedious. They are easy, but they are time consuming, right? Therefore, you also need some sort of programming, the automatic program which can perform these calculations. So therefore, came the word there, the simulation there, that you want to write a program so that repetition calculation, long calculations, or a tedious calculation which need a lot of time can be done on your PC actually, right? So lab you have in the next semester, right? Or you have in this semester?
So this semester.
Who is taking the lab?
Anurag sir.
Okay. So he will tell about the programming of these actually, how to program. Then you have next one is Newton's divided difference interpolation part here. So this is also another technique. So this is also given that divided the difference is given of first one here for argument x0 and 1. So you are just calculating a difference of two function values f0 and f1 and difference in x values here. So that is called some sort of the derivatives, right? Or derivatives also you are calculating all the time. Delta f upon delta x or delta y something, right? So this is first difference, then you are calculating again with respect to point 1 and 2. So fx1 minus fx2, then with respect to point 3. So you are calculating differences with respect to all points. Fine. You can calculate with all points. Now let's see what you have next here. Second difference also can be calculated. So first you have calculated first derivative. You can calculate also second derivative or second difference here. So second difference also would need your 3 points now. x1, x0, x1, x2. Because x1, this also need your first derivative. First is of a difference. This also needs first between 1 and 2. So total range of data is now from x0 to x2. So this is the second divided difference. Then you can calculate second, same way you can calculate your third divided difference. Third would be calculated based on this one and this one. x0, x1, x2 minus of x1, x2, x3. So you can calculate third divided the difference in that way. So once you have all divided differences, this is third one here. And then for first divided in the order 1, second in order 2, order 3. So as we have more and more orders of functions, we always go close to good fit actually of the data actually. So this is the order of differences are concerned, as you have more and more, you will get more and more correct answer actually. Now, how to calculate your divided difference table? So this is same as you have previous one. So first you have your data x here, x1, x2, x3. Now you have data of y, which is your function value fx1, fx0, fx1, 2, 3, 4, 5. Now here there is no constraint that you should have equally spaced data point or that. Previously Newton forward, backward, central, you have equally spaced data points, and the differences between oh, hello. So here also you can calculate your the difference actually. So based on first two the data point, the difference would be this minus that this one divided by of x1 minus x0 only. So this you have calculated first difference, second difference, third difference, and fourth. Then second order one, then third order, then fourth order, then fifth order. So here only in previous one on here the difference is you are dividing always by the difference of two values of x also. In case of previous one you are just calculating y1 minus y naught or y2 minus y1, something like that, correct? So they are not there you are not dividing with the differences of x variables there. Here are you doing that. So therefore this is called divided difference table only. Is that fine?
Yes, sir.
After that, once you have this divided difference table, this is the another way just to show that because the previous one what you have calculated first divided the difference for argument x0 and x1, function value at fx1 minus function value at fx0 divided by x1 minus x0 only. So that is the calculation in the procedure. For x1, x2, your x0 has been changed by x1. For x3, x2 you have this again function value at x3 minus function value x2 divided by x3 minus x2. So this is the way you will calculate your divided differences. Fine. Now based on that hello. So based on that you are calculating your difference formula in this actually. So this is your Newton's divided difference interpolation formula. Just to calculate your function values at any given values here. So what you have here, you are having fx naught. This is your first divided difference. You have here multiplied by x minus x naught, and then you have the second divided difference here. Then you have Then you will continue here. Then you are calculating here fx naught. So this is your argument 1, 2. This is argument here. You have 3 here also 3 here you 4, and then you keep on continuing here. So this is the way you will calculate your function value from divided difference here. So let's see one calculation from here. I hope you can understand from that. So what you have here, let's say this is your example here. These are your total number of the data point. First you can say 0, 1, 2, 3, and 4. So these are the number of the data points. Values of x are 0, 1, 2, 3, and 4. Corresponding function values are 0, 1, 8, 27, 64. These are corresponding value of functions. Now you are calculating first divided the difference. So how would you calculate first? This function value minus this divided by this value of x minus this. That's what you have here. So this 1 minus 0 divided by this 1 minus 0, you are getting here 1. Now for this one, for these two arguments, your function value is 8, 1, so 8 minus 1. X values are 2, 1, so this is again 2 minus 1 here. You got 7. Now for this 27 minus 28 divided by 3 minus 2, you got 19. From here you got 37 that way. So this is your, this column is first divided difference column. Then you can have your the second divided the difference column. From here now you are calculating based on these, based on this one and here. Now till this particular point you have reached to the point x equal to 2. Here is x equal to 0. So total the difference in x here 2 minus 0 here. So you got here this one. Now this 19 minus 7 divided by 3 minus 1, because you are calculating differences based on these two values 1 and 3. Same thing for this. So you have here 37, then 19, 19 corresponds to 2 and 37 corresponds to 4. You will calculate this. Then again third order the difference is same way, then fourth order the difference is same way. So you have calculated all your first order the difference, second order difference, and third order difference, and fourth order. So that way you will calculate your difference table. Is that fine?
Yes, sir.
Yes, sir.
Right.
Yes, sir.
Now next part is there. You have another example here that you are calculating again the difference table for these two data points. So here data is x equal to minus 2, 0, 1, 3. And then you are calculating here, these are your function values or y. Now you are calculating differences. Here, this minus that divided by 0 minus 2. So this is here 21. You will get this also, this one. Then after that you keep, this is your, these are your the differences. After that you can substitute in your power difference table, and then you are calculating this is your equation of your power difference. Now here you can substitute your value of x, you can calculate your function value at any x. So this is just one sort of fitting. आपके पास एक polynomial, you got a polynomial. Now you change your x only, you will get your the unknown function value. So it looks just like some sort of polynomial fitting, which we were doing in Excel sheet automatically. Yes or no?
Yes.
Yes, sir.
Right? So this is same thing. So you have just some sort of polynomial fit you did. So obviously from here you may get something better answer than in power difference actually. Now the another interpolation technique is, do we have time? So the interpolation is Bessel's formula there. So in Bessel's formula of the interpolation is given by this. This is based on Newton's power interpolation. So this is given here. So this U is practically same as alpha because previously we have taken the alpha here. So this is YP, means the unknown value is Y naught and this is calculated from here. So this is based on your forward difference here. So here you got, this is the Newton's means the Bessel's formula. So same way the interpolated values or function values can also be calculated by same way. And these tables I think you already know how to calculate del square y minus y1. Have you calculated these difference tables? You have already. We can see here. This is your Bessel's formula based on central dot difference. Previous one from your forward and backward. This is now from the central dot difference. Now you are going from the center, you are expanding to this side here. So derivation of this also can be done, but we are not doing the derivation. We are taking this. This is the Bessel's interpolation formula for based on center difference only. Let's see how to calculate this mu del square y1 2 so you will come to here. So your center means the difference one del y1 is being calculated by this only. Fx at your total interval size was h, so you are going h by 2 to forward and h by 2 to the backward so that you can come to the center only. So this is known your y value at I plus 1 by 2. This is known when you are going to backside. This is known at y value at I minus 1 by 2. So this total is, so this is your the first center difference del y1. Okay. Now you need del y1 by 2. It means that y1 minus y0 only. That's called del y1 2. Hello?
Yes, sir.
So these are just nomenclature. This is known as del y1 of function value at I plus 1 by 2 at I minus 1 by 2. After that you have one more term del y 1 by 2 is being known as this one y1 minus y0. Then 3y2 is known y2 minus y1. So same these are the first central the differences here because here you don't have power. Second central you are putting here del square here, that is called the second central difference here. This is again you are calculating here that y1 plus I by 2 and y minus I by 2 and you can substitute here from this one, and finally a generalized formula is given by this. If you are just calculating any del, this is your generalized formula del to the power n yi equal to del to the power n minus 1 yi plus n by 2 and del to the power n minus 1 yi minus 1 by 2. So you can substitute your any value of n, you will come back to the required formula. Let's say you are putting n equal to 1. If you will put n equal to 1 here, what will you get? You will get first formula. Hello?
Yes, sir.
Yes, sir.
If you put n equal to 1, you would be here. N equal to 1 and I equal to 1. You would be in first formula here. If you put n equal to 2, you would be here actually. Fine. So that way you can calculate all your center differences here. So this is the problem from here. I hope you can understand how to apply your Bessel's interpolation formula. So you have here x values 20, 24, 28, 32. These are your values of x. Corresponding values of y are here. You have 2860, 3167, 5. 4112. These are your function values here. Now, here actually you don't know that where would you put your central line type of thing here. Central line, where would you put here? So because you don't have Python, you have 5 data, so you can put the third point, the center point. Yes or no?
Yes, sir.
Yes, sir.
Right? So you don't have here. So you have a confusion here. Where should I go? Either here or here. So the question is there. We should choose your x naught a point which is close to your unknown value. So unknown you are calculating at y equal to you are interested to calculate y at x equal to 25. So x equal to 25 is close to this value 24. So that's why you are denoting this point as x naught. So that is the way to fix up your x naught actually in phase of the Bessel's interpolation. Is that fine? You just check where are you calculating. Okay?
Yes, sir.
Okay, sir.
Yes, sir.
Uh, then here you have your formula here that you have x naught is finalized now 24. H is the difference between the interval size. So here you see the variation is 4 here. This is also 4, this is also 4, this is also 4. So the interval size is 4. You can calculate a u. U is practically x minus h naught divided by h only. That's what is the u or alpha there. So from here you got the u is 0.25. Fine?
Yes,
Hello?
sir.
Then you can apply your Bessel's formula. So Bessel's formula is for Hello, sorry, I got some. Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
I can see this camera. So you have here your x here. You have calculated alpha or u from here. Now you can use your from Bessel's formula. So this is your Bessel's formula here actually. So this you have del square by minus 1 by naught and all this. So you have here, all this is your complete formula for that. Now you have your values, so you can substitute that from where these values will come. You have y naught there. This is what you have. Okay. Y naught is belongs to which one? Where is y naught here? This one, 3164,
Yes, sir. Yes, sir.
67.
Yes, sir.
That's what your y
316.
naught. Your u is this 0.25. You have delta y0. So delta y0 388. So this is your first one, delta y0. So you have this is delta minus y1 and this is delta y. So you have this first all term in first here of this one. Now you have this one that u minus 1. So u is 0.25. U minus 1 0.25 minus 1 divided by 2. Now you have delta square minus y1 and delta square by naught. So you have those values from the graph. Delta square, your second derivative table. This is your second derivative table. Okay?
Yes,
This is
sir.
minus y1 and this is your y1 here. So that's y naught here. So you have this value here, 61 here. 81 and 61 here. Now you have third term. Here you have all your u that 0.25, 0.25 minus 1, 0.25 1 by 2. Now you have delta q y minus 1. So that is from here. You have only this value here. So you have those values. So all of them, you can say the previous one, power difference, backward. This table is everywhere same, right? Yes or no?
Yes, sir.
Yes, sir.
Right? Only thing you got different applications to calculate, and finally from here you got the answer. So your previous question which you are talking for, penciling one, can also be done by Bessel's formula also, because you have the technique also there, so you can use that also technique. Now your class time is over. So we will explain this in the next class, the Sterling's formula also. So Sterling's also one of the means another technique just to calculate your interpolation again. So this is being calculated based on Newton's forward and backward the difference, and practically you are taking the average of them. So you will see here also forward and backward average, forward and backward average. Here also average you are taking. So all the places you are taking forward and backward average of 2, and this is your formula for Bessel's interpolation formula actually. So this you can write it maybe in expanded form again. So you have a Q. Previously you are taking U here. So Q, U, and alpha, all of them are same only. So these are the different pictures actually. So you can write here in the expanded form here. First term, then second term, then third, then fourth, fifth, and keep on expanding here. So that way you can define your general expression for your at any point here. This would come from here. So this 2n minus 1. So that way you can write your Stirling's formula also there. So once you have this is again your table. You are calculating again table. So this you have the center point here. x1, x2, minus 1, 1, 2 here. Then you have y. You are calculating differences there. So this is the minus 1, minus 2. This is 0, 1. Then again minus 1, 0, 2. So that way this table proceeds actually. So that you should know which term would considered as minus 1, which is considered as minus 2. So that is from here. 1, 0, minus 1, minus 2, 0, 1. Then minus 1, minus 2, 0. And here you will continue here, minus 1, minus 2. Then again you have minus 2 there. So that way it will proceed structure, the table actually. So you should know this, the nomenclature properly. This is again the same way. So you are just putting here minus 2, minus 1. So third difference, second difference, fourth the difference is there. So we will end up the class here. So we will do all these calculations in the next class there. So in the next class, you would complete your forward difference, backward difference, and Lagrange for that particular question for polynomial one. I mean penciling one. Okay?
Okay, sir.
Fine. So maybe you can do in your the Excel sheet or maybe your notebook. Choice is completely yours, but try to complete that. And then you have the columns that these are the different values from different techniques. Fine. At the same time, all of you might have your computers, so you can do that polynomial fit also, and let's see what is coming from there. You have your computer, everybody?
Yes, sir.
Yes, sir.
Yes, sir.
So just put those data in the Excel sheet, and then you say the fifth order polynomial is fitting good. So try to use that line also. That's the from value from polynomial fit. So let's see what is coming. Okay? Okay
sir.
then. Bye. We'll close them.
Thank you,
Thank you,
sir.
sir.
Yeah, bye.